Hello and welcome to today's lesson on writing and naming ionic compounds. So we've done the basics already. Now we're going to get into the writing and naming part that's going to continue on through the remainder of the year. So today, goals. I want you to understand Roman numerals 1 through 10, so I through X. We're going to write the correct formula for an ionic compound given the name. You will be able to name ionic compounds given the formula. So let's get started. First off, Roman numerals 1 through 10. 1 is I, 2 is 2 I's, 3 is I, 4. If you write the smaller Roman numeral in front of the bigger one, you subtract. So I is 1, V is 5. So 1 less than 5 is 4. Then we get 5, we get VI. So again, if bigger than smaller, you add. So VI, VII, VIII. And then I go 1 less than 10. So I and then X. And then 10 is just X. Those are the Roman numerals you will need for this course in particular, but it's always nice to know anyways. Today, writing ionic formulas. In order for us to write formulas, the first thing that needs to happen is you look at the name. You're going to write the cation symbol and valence number, followed by the anion symbol and valence number. If there's a Roman numeral behind the cation, that is the valence number, and we'll look at that and what that looks like here in a second. Follow that, we're going to cross and drop valence numbers along with the signs. I'll explain that. And then we'll reduce with common multiples so we can get to our smallest whole numbers there. So we're going to practice, which will make a lot more sense than these rules. But I would like you to write these down so you have them. Okay, so for starters, we have magnesium and chloride. Magnesium chloride. So we have magnesium and we have chlorine. First one, write the cation and the charge. Magnesium is in column 2, which means it has a charge of positive 2. Chloride refers to chlorine, which is found in column 17, which has a charge of negative 1. So I have symbols and charges. The next step is going to be to cross and drop. So I'm going to take my 2 and I'm going to cross it and drop it. Take the negative 1, I'm going to cross it and drop it. I'm going to drop the signs as well, which is going to leave me with Mg1, Cl2. And then I can get rid of the 1 because it's a number I don't need, so I can just write MgCl2. And this creates a neutral compound because magnesium has a charge of positive 2. So I have 1 magnesium times positive 2 equals positive 2. Chlorine has a charge of negative 1. I have 2 of them. Negative 1 times 2 equals negative 2. Positive 2 plus negative 2 equals 0. That's what we're looking for. Aluminum oxide. Symbol for the cation is Al. Charge for aluminum is positive 3. Oxide refers to oxygen. Symbol is O. Charge is negative 2. We're going to cross and drop 3 and 2. So I'm going to end up with Al2O3. I can't simplify that, so that's going to be my answer. Ammonium sulfate. So ammonium, symbol is NH4. Charge is positive 1. Sulfate, formula is SO4, SO4, charge is negative 2. I'm going to again cross and drop. This time, because I'm dealing with polyatomics, I'm going to put the whole polyatomic in parentheses. So I have NH4, parentheses, 2, parentheses, SO4, parentheses, 1. Because I have a 1 here, I can change this to write, I need this 2 because I have 2 ammoniums, but then I can just write SO4 here like so. So this is going to be your ammonium sulfate. And the last one's iron 2 phosphate. So I have Fe with a charge of plus 2. I have phosphate, which is PO4, with a charge of negative 3. So I'm going to cross and drop. I'm going to get Fe3, parentheses, PO4, parentheses 2. So that is what you're going to do. I have some practice ones for you on the next slide and answers to follow. So here are some for you to practice. And then when you get these done, if you hit play again, I'll give you the answers on the next slide. So here are your answers. Some to be careful with. Copper 2 sulfite. You have Cu plus 2, SO3 minus 2. You cross and drop, which gives you Cu2, SO3, 2. Because these are the same, I can simplify. Divide them both by 2, and I get 1. That's where we get CuSO3. Same thing here. Lead 4 sulfate should have been Pb2SO4 4. I divided both by 2 and got PbSO4 2. We'll do more practice with that, but that is what we're looking at there. All right, so that's writing formulas. Now we're going to name them. So when we're naming ionic compounds, first you identify the cation and the anion. When you name them, the cation name stays the same. You write just the name of the element. On the anion, you're going to take the stem or the base of the element and keep it the same. You're going to change the ending to IDE. For example, oxygen becomes oxide. Sulfur becomes sulfide. Fluorine becomes fluoride. Bromine becomes bromide. Nitrogen becomes nitride. All of those. If you have a polyatomic ion, keep it the same. Sulfate stays the same. Chlorate stays the same. Hypobromite stays the same. If it's a multivalent cation, most of these are transition metals. You're going to use Roman numerals to indicate valence or oxidation states. And then the cation name always goes first. We're going to practice a couple, and I'll give you some that you can try on your own. For example, we have AgNO3. So Ag is silver, NO3 is nitrate. This becomes silver nitrate. So write the name of your cation, silver, and because this is a polyatomic, I just need to leave it as nitrate. Here we have calcium and we have SO4, which is sulfate. So again, calcium and sulfate is there. And our last one is FeOH3. So Fe is iron. And iron has two charges, iron 2 and iron 3. But I have hydroxide here, which we know is -1. So if I have 3 of them, and this is neutral, I know that my iron has to be -1 times 3 equals -3 plus X equals 0. I know iron's got to be a +3. And because iron is a multivalent atom, I need to know it is iron 3 hydroxide there. Here are some practice ones for you to try. So again, name the cation and change the anion ending unless it is a polyatomic. So try your luck on these, and then I'll give you the answers here on the next slide. So you should have potassium chloride, ammonium sulfate, aluminum phosphate, cobalt-2 selenide, because cobalt is a transition metal, and then barium cyanide should be our last one. If you struggled with this, don't worry, we will have plenty of more opportunities to practice, but please get these down as examples so you can reference them in the future. All right, some review questions for you. I need to know the 2 parts of an ionic compound. What are they made of? Which one is named first? What do Roman numerals indicate in the name? And then give you the name or formula for these 6 compounds here. Thank you for your time and attention. I look forward to continuing this unit with you. Let me know if you have any questions. Otherwise, I will talk to you later.